Now in this lecture we will find out the value of angle x using two different methods. In the drawing we have triangle PQR. We know that QS is equal to SR. We also know that angle PSQ is equal to 45 degrees. Angle QPS is equal to 3x. Angle PRS is equal to x, and we want to find out the value of angle x. So we will start with the first method. We will define angle QPS as alpha and angle SPR, this angle is beta, and we will define angle PSR as y, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line QR, then according to the rule that I mentioned, the sum of its angles at point S must be equal to 180 degrees. That is to say, 45 degrees plus the size of angle Y must be equal to 180 degrees. So I'll write it down. So here we will subtract from this equation 45 degrees, and we will get that angle Y equals to 180 degrees minus 45 degrees is 135 degrees. So we found out that angle Y equals to 135 degrees, so we can substitute Y by 135 degrees. In the next step, I will present to you a new rule. It is called the law of sines. According to the law of sines, the law of sines is true in any triangle. So you can write down that in any triangle, if we have a triangle in this triangle, we know that the length of this side is A units, the length of this side of the triangle is B units, and the length of this side of the triangle is C units. And we also know that this angle is equal to A degrees. The size of this angle is C, and the size of this angle is B. Then, according to the law of sines, A over sinus A equals to B over sinus B equals to C over sinus C in any triangle A, that is the length of this side over sinus A, equals to B over sinus B equals to C over sinus C. So from this formula we derive that A over sinus A is equal to B over sinus B we will divide this equation by B and then we will multiply it by sinus A and we will get that A over B equals to sinus A over sinus B. Okay, so what is the meaning of this equation? The meaning of this equation is that the ratio between the side lengths of any triangle of any triangle is equal to the ratio between the opposite angles. So the meaning of the equation that A can be, the meaning of the equation that A over B equals to sinus A over sinus B is that the ratio between the side lengths of any triangle, that is to say A over B, is equal to the ratio between the opposite angles, that is to say sinus A over sinus B. Okay? Because of the fact that angle A is located in the opposite sides of this side and angle B is located in the opposite side of this side, it is actually the ratio between the left sides is equal to the ratio between the opposite angles. Okay? So we'll return to our original drawing. In our original drawing, we can create equation number 1 that says that PS over QS is equal to PS over SR. I'll repeat on equation number 1. PS over QS equals to PS over SR. And why equation number 1 is true? Equation number 1 is true because of the fact that QS is equal to SR. Therefore, PS over QS is equal to PS over SR. Okay? And according to the equation that A over B is equal to sinus A over sinus B, the value of PS over QS, if you focus on triangle PQS, it is equal to the ratio between the opposite sides. It is equal to the ratio between the opposite angles. That is to say, PS over QS will be equal to sinus 3x over sinus alpha. I will repeat again. According to the equation that A over B is equal to sinus A over sinus B, we will get that if we focus on triangle PQS, we will get that PS over QS equals to sinus 3x over sinus alpha. And if we focus on triangle PSR, then PS over SR. In triangle PSR, PS over SR will be equal to sinus X over sinus beta. Okay, PS over SR, if we focus on triangle PSR, will be equal to sinus X over sinus beta. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle PSR, the sum of the angles must be equal to 180 degrees. So first of all, we will focus on triangle QPS. On triangle QPS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. In triangle QPS, the sum of the angles is equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. If we subtract 45 degrees and also 3x from this equation, equation number 2, we will get that angle alpha will be equal to 180 degrees minus 3x plus 45 degrees. So we actually found the value of angle alpha in terms of x. Likewise, if we focus on triangle PSR. On triangle PSR, the sum of the angles must be equal to 180 degrees. So it means that angle beta plus 135 degrees plus angle x must be equal to 180 degrees. So in triangle PSR, the sum of the angles is equal to 180 degrees, that is to say beta plus 135 degrees plus x must be equal to 180 degrees. Here we will subtract 135 degrees and also x from equation number 3, and we'll get that angle beta will be equal to 180 degrees minus 135 degrees is 45 degrees, and we also subtracted x from equation number 3, so it is 45 degrees minus x. So we found out that angle beta equals to 45 degrees minus x, and angle alpha equals to 180 degrees minus 3x plus 45 degrees. So now we can substitute alpha and beta on this equation number 1, by the values that we found for alpha and beta in equation number 2 and equation number 3. So we'll do it now, and we will get that sinus 3x, according to equation number 1, sinus 3x over sinus alpha, and alpha according to equation number 2, this equation, it is equal to 180 degrees minus 3x plus 45 degrees. Okay, and so according to equation number 1, it equals to sinus x over sinus beta, and beta according to equation number 3, it equals to 45 degrees minus x. And we also have the trigonometric identity that states that sinus 180 degrees minus theta equals to sinus theta. Sinus 180 degrees minus theta equals to sinus theta. According to this trigonometric identity, we will get that sinus 180 degrees minus 3x plus 45 degrees will be equal to sinus 3x plus 45 degrees. So we will change this expression by sinus 3x plus 45 degrees in equation number 1, and we will get that According to equation number 1, sinus 3x over sinus 130 degrees minus 3x plus 45 degrees equals to sinus 3x plus 45 degrees. So I write it down. And it equals to sinus x over sinus 45 degrees minus x. So here we will cross multiply equation number 1, and we will get that according to equation number 1, sinus 3x minus sinus 45 degrees minus x is equal to sinus x times sine 3x plus 45 degrees. So here we will multiply this equation number 1 by 2, and we will get that two times sinus 3x times sinus 45 degrees minus x equals to 2 times sinus x times sinus 3x plus 45 degrees So here we will use the trigonometric identity that states that 2 sine A sine B is equal to cosine A minus B minus cosine A plus B. Okay, so we will use this trigonometric identity in order to simplify the expression 2 sine 3x times sine 45 degrees minus x, and here the value of A will be equal to 3x and the value of B will be equal to 45 degrees minus x, so 2 sine 3x sine 45 degrees minus x will be equal, according to this trigonometric identity, cosine A minus B. Cosine A minus B. A is 3x, B is 45 degrees minus x, so 3x minus x is 4x, and 0 minus 45 degrees is minus 45 degrees, and we also have to subtract cosine A plus B. So A plus B, A is 3x, B is 45 degrees minus x, so A plus B is 3x plus minus x. 3x plus minus x is 3x minus x, that is to say 2x. And 0 plus 45 degrees is 45 degrees. Okay, so we finished with the expression 2 sine 3x sine 45 degrees minus x. According to this trigonometric identity, it equals to cosine 4x minus 45 degrees minus cosine 2x plus 45 degrees. Now we will treat the other expression in the other side of the equation number 1. That is to say, we will treat the expression 2 sine x sine 3x plus 45 degrees. Here a equals to x and b equals to 3x plus 45 degrees. And according to this trigonometric identity, it equals to cosine a minus b. So it is actually cosine a is x and b is 3x plus 45 degrees. X plus 3x is 4x. So it is actually x minus 3x because it is cosine a minus b. So x minus 3x is minus 2x. And 0 minus 45 degrees is minus 45 degrees. So here we got that cosine a minus b, it is actually cosine minus 2x plus 45 degrees. But according to the trigonometric identity, that cosine minus x is equal to cosine x, we can change the negative sign in cosine minus 2x plus 45 degrees to a positive sign, because cosine minus x equals to cosine x, and we will get that cosine minus 2x plus 45 degrees, it is actually cosine 2x plus 45 degrees. We change the negative sign to a positive sign. Okay, and here we also must to subtract cosine minus cosine a plus b. So it is minus cosine a is x and b is 3x plus 45 degrees. So a plus b, it is actually x plus 3x is 4x, and 0 plus 45 degrees is 45 degrees. So in conclusion, we found out that cosine 4x minus 45 degrees minus cosine 2x plus 45 degrees equals to cosine 2x plus 45 degrees minus cosine 4x plus 45 degrees. So we have here cosine 4x minus 45 degrees. We will add to this equation number 1, cosine 4x plus 45 degrees. So here it is plus cosine 4x plus 45 degrees. And it equals to cosine 2x plus 45 degrees minus cosine 4x plus 45 degrees. So here we have minus cosine 2x plus 45 degrees. So we will add cosine 2x plus 45 degrees to this equation number 1, and we will get cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees is equal to 2 cosine 2x plus 45 degrees. Actually, the expression cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees is very similar to the trigonometric identity that cosine C plus cosine D is equal to 2 cosine C plus D over 2 times cosine C minus D over 2. So we will use this trigonometric identity in order to simplify this expression cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, and the expression 2 cosine 2x plus 45 degrees is very similar to the trigonometric identity that says that cosine A plus B is equal to cosine A cosine B minus sine A sine B. So we start with the expression cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees, and according to the trigonometric identity that cosine C plus cosine D equals to 2 cosine C plus D over 2 times cosine C minus D over 2. So here in our specific expression, C is equal to 4x minus 45 degrees and D is equal to 4x plus 45 degrees. So cosine C plus cosine D equals to 2 cosine C plus D over 2. That is to say 2 cosine C plus D over 2. Here C is 4x minus 45 degrees and this is 4x plus 45 degrees. So C plus D is 4x plus 4x. That is to say it is 8x, and 8x over 2 is 4x. And minus 45 degrees plus 45 degrees is 0. So in conclusion, we found out that cosine 2 cosine C plus D over 2 is actually 2 cosine 4x, and we also must multiply it by cosine C minus D over 2, and cosine C minus D over 2 it is C is 4x minus 45 degrees and D is 4x plus 45 degrees. So C minus D is 4x minus 4x is 0, and we also here minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. So we got cosine minus 45 degrees, but because of the fact that cosine minus x equals to cosine x, we can change cosine minus 45 degrees to cosine 45 degrees. So we got here cosine 45 degrees. Cosine C minus D over 2 is actually cosine 45 degrees. So we finished to treat this expression. Now we will deal with the expression 2 cosine 2x plus 45 degrees, and we will simplify it by the trigonometric identity that cosine A plus B equals to cosine A cosine B minus sine A sine B. So here A is equal to 2x and B is equal to 45 degrees. Therefore, cosine A plus B is cosine A cosine B, that is to say cosine A is cosine 2x because A equals to 2x. And cosine B is 45 degrees, so it is cosine 45 degrees. And we also must to subtract sine A sine B. A is 2x, so it is sine 2x. And B is 45 degrees, so it is sine 45 degrees. So in conclusion, we got this expression. So here we will divide this equation number 1 by 2 cosine 45 degrees. So here 2 cosine 45 degrees will get cancelled, and also here 2 cosine 45 degrees will get cancelled. And because of the fact that sine 45 degrees is equal to cosine 45 degrees, in this expression 2 sine 45 degrees will get cancelled. And what is left from equation number 1 after we cancel 2 cosine 45 degrees? What is left? It is actually, according to equation number 1, cosine 4x is equal to cosine 2x minus sine 2x. Okay, so actually, I'll repeat again, according to equation number 1, cosine 4x equals to cosine 2x minus sine 2x. Here we will add to this equation number 1 sine 2x, and we will subtract cosine 4x. And we will get that here sine 2x is equal to cosine 2x minus cosine 4x. Actually, sine 2x is 2 sine x cosine x. So I write it down. 2 sine x cosine x. And cosine 2x minus cosine 4x is very similar to the trigonometric identity that cosine C minus cosine D is equal to sine D plus C over 2 times sine D minus C over 2. So I write it down. Cosine C minus cosine D is equal to sine D plus C over 2, 2 sine D plus C over 2, times sine D minus C over 2. So we use this trigonometric identity in order to simplify cosine 2x minus cosine 4x, and we will get that here actually C equals to 2x and d equals to 4x, and according to the trigonometric identity, cosine c minus cosine d equals to 2 sine d plus c over 2. So it is 2 sine d plus c over 2 is c is 2x and 4 and d c is 2x and d is 4x. So c plus d is 2x plus 4x, that is to say 6x, and 6x over 2 is 3x, so we got here 2 sine 3x, and we also must to multiply it by sine d minus c over 2. Sine d minus c, d is 4x, c is 2x, so 4x minus 2x is 2x, and 2x over 2 is x. Okay, so we found out that 2 sine cosine x equals to 2 sine 3x sine x. Here we will divide this equation number 1, by 2 sine x, and we will get that here 2 sine x will get cancelled, and also here 2 sine x will get cancelled. What is left from equation number 1 after we cancel 2 sine x? What is left is actually here we have cosine x. And on the other side of equation number 1, we left only with sine 3x. So we got that according to equation number 1, cosine x equals to sine 3x. So here we have the trigonometric identity that that cosine alpha equals to sine 90 degrees minus alpha. According to this trigonometric identity, we will get that cosine x is equal to sine 90 degrees minus x, and it equals to sine 3x. Sine 90 degrees minus x equals to sine 3x means that 90 degrees minus x equals to 3x. So here we will add x to this equation number 1, and we will get that 90 degrees equals to 3x plus x is 4x. We will divide the equation number 1 by 4, and we will get that x equals to 90 degrees over 4. 90 degrees over 4 is 22.5 degrees. So we found out, according to the first method, that the value of angle x is equal to 22.5 degrees. Okay, I will repeat again. The value of angle x, according to the first method, is equal to 22.5 degrees. So we finished with the first method. In the next step, I will present to you how to find out the value of angle x according to the second method. In the second method, we also define angle QPS as alpha, as we did in the first method, and angle SPR as beta. And we already found out that angle PSR, this angle, is equal to 135 degrees. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle QPS, in triangle QPS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. I'll repeat again. The sum of the angles in triangle QPS must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. Here we will subtract 45 degrees from this equation, equation number 1, and we will get that alpha equals to alpha plus 3x equals to 180 degrees minus 45 degrees is 135 degrees. So according to equation number 1, we found out that alpha plus 3x equals to 135 degrees. We will do the same process on triangle PSR. In triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, angle beta plus 135 degrees plus angle x must be equal to 180 degrees. I repeat again, the sum of the angles in triangle PSR must be equal to 180 degrees. That is to say, beta plus 135 degrees plus x equals to 180 degrees. We will subtract 135 degrees from this equation, equation number 2, and we will get that beta plus x equals to 180 degrees minus 135 degrees is equal to 45 degrees. Here we will multiply equation number 2 by 3. We will get that 3 beta plus 3x equals to 135 degrees. So according to equation number 2, 3 beta plus 3x equals to 135 degrees, and according to equation number 1, alpha plus 3x also equals to 135 degrees. So we can create equation number 3 that says that equation number 1 is equal to equation number 2, because in both equations one side of the equation is 135 degrees. So we can create equation number 3 that states that this side of equation number 1, that is alpha plus 3x, equals to this side of equation number 2, that is 3 beta plus 3x. Okay? We will subtract 3x from this equation, equation number 3, and we will get that alpha equals to 3 beta. We found out that according to equation number 3, alpha equals to 3 beta. In the next step, we will do a construction from point Q. We will draw a straight line to side PR in such a way that the angle that will be created here will be equal to x. Again, we did the straight line in such a way that this angle will be equal to x. So if this angle equals to x and angle PQR equals to 3x, then 3x minus x will be equal to this angle, that is to say angle PQ, this angle will be equal to 2x. Okay? Because 3x minus x is the value of this angle, that is to say it equals to 2x. And we will define the touching point between the straight line and PR as point M. Actually, triangle QMR is an isosceles triangle. Why? Because it has two angles that are equal to each other, they are both equal to x. Okay, and the base of the isosceles triangle QMR is QR. We will join points M and S together by a straight line. Actually, line segment MS is the median to the base in the isosceles triangle QMR. Why it is the median? Because it bisects the base QR into two equal parts. That is to say, QS is equal to SR. According to what is given in the question, QS is equal to SR. Okay? QS equals to SR, therefore the median MS bisects the base QR, and according to rule number 3, the median to the base in the isosceles triangle QMR, it is not only bisects the base, but it is also perpendicular to the base. That is to say, this angle is equal to 90 degrees, and this angle also equals to 90 degrees. Okay? In the next step, actually in the question it is given us that QS equals to SR and angle PSQ is equal to 45 degrees. Okay, so in the next step I will present to you a new rule number 4. According to rule number 4, the exterior angle of a triangle is equal to the sum of the angles to the sum of the two angles that are not adjacent to it. So I will read rule number 4 again. According to rule number 4, the exterior angle of a triangle is equal to the sum of the angles that are not adjacent to it. Okay? So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have triangle ABC, so this is triangle ABC. We know that this angle is equal to alpha, this angle is beta, and this angle is gamma. So here, alpha, beta, and gamma are the interior angles of triangle ABC. And this angle why alpha, beta, and gamma are the interior angles of triangle ABC? Because of the fact that they are located inside triangle ABC, while angle SAB, this angle is defined as the exterior angle of triangle ABC because of the fact that it is located outside triangle ABC. Therefore, it is defined as an exterior angle. And according to rule number 4, the exterior angle of a triangle, that is to say angle SAB, is equal to the sum of the two angles that are not adjacent to it. Angle gamma is adjacent to angle SAB, and the two other angles that are not adjacent to angle SAB to this angle are alpha and beta. And according to rule number 4, the exterior angle SAB is equal to the sum of the two angles that are not adjacent to it. That is to say, it equals to alpha plus beta. The sum of the two angles that are not adjacent to the exterior angle SAB is actually alpha plus beta. Okay, the two angles that are not adjacent to it are alpha and beta, and the sum of the two angles that are not adjacent to it is equal to alpha plus beta. So the value of the exterior angle SAB according to rule number 4 is alpha plus beta. Okay, so we can implement rule number 4 in our drawing, because in our drawing we have the isosceles triangle QMR. Those two angles and also this angle are defined as interior angles, while angle PMQ, this angle is defined as the exterior angle of triangle QMR. And according to rule number 4, the value of the exterior angle PMQ, this angle, will be equal to the sum of the angles that are not adjacent to it. This angle is adjacent to it, and the other two angles that are not adjacent to it are those two angles, and the sum of those two angles is x plus x. That is to say, the exterior angle PMQ, according to rule number 4, equals to 2x. Okay? And here, triangle PQM is an isosceles triangle because of the fact that it has two angles that are equal to each other. Both those two angles are equal to 2x. Triangle PQM is an isosceles triangle, and we have the rule that in front of equal angles in the triangle there are equal sides. In front of those two equal angles we have sides PQ and PM, and they are equal to each other. PQ equals to PM according to the rule that in front of equal angles in the triangle there are equal sides. So PQ equals to PM. We found out that PQ equals to PM. Okay. In the next step, we will draw perpendicular from point P to QM, and then we will extend the perpendicular until it touches QS. So here, first of all, we will draw perpendicular to QM from point P. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Then we will extend the perpendicular until it touches QS, and we will define the touching point between the perpendicular to QS as point N. We will focus on those two triangles. First of all, we will define the touching point between the perpendicular from point P to QM as point L, and we will focus on those two triangles, triangle PQL and triangle PLM. I'll repeat again, we'll focus on the right triangle, triangle PQL, and the right triangle, triangle PLM. On those two triangles, we have two angles that are equal to each other, they are both equal to 2x. So angle PQL equals to angle PML, and both angles are equal to 2x. Angle PQL equals to angle PML, and both angles are equal to 2x. Okay? And those two angles, they are also equal to each other. They are both equal to 90 degrees. So angle PLQ on triangle PLQ is equal to angle PLM, and both angles are equal to 90 degrees. I will repeat again. Angle PLQ equals to angle PLM, and both angles are equal to 90 degrees. Those two angles, they are also equal to each other according to third angle theorem. So this angle, that is actually angle PQL, equals to this angle, that is actually angle LPM, angle LPM So actually angle QPL equals to angle LPM according to third angle theorem. Third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. Why? Because it is complementary to 180 degrees. The value of the third angle is equal to 180 degrees minus the sum of the two other angles, but the two other angles are equal in both triangles, so for that reason the third pair of angles must be equal to each other. And we actually here found out that those two angles in triangle PQL congruent to those two angles in triangle PLM, therefore the third pair of angles must be also congruent. That is to say, those two angles must be equal to each other. Okay? So, because of the fact that those two angles are equal to each other, so if we define angle QPL as theta, then angle LPM will be also equal to theta because of the fact that those two angles are equal to each other. And from the drawing you can see easily that theta plus theta, that is actually this angle, is equal to alpha plus beta, the same angle. Theta plus theta equals to alpha plus beta. So theta plus theta equals to alpha plus beta. Theta plus theta is 2 theta, and it equals to alpha plus beta. We have already found out, according to equation number 1, that alpha equals to 3 beta. So here we can substitute alpha by 3 beta. We will do it and we will get that 2 theta equals to alpha is 3 beta plus beta. So 2 theta equals to 3 beta plus beta is 4 beta. Here we will divide this equation by 2 and we will get that theta equals to 4 beta over 2 is 2 beta. 4 over 2 is 2, so theta equals to 2 beta. We found out that theta equals to 2 beta. So here we can write down that theta equals to 2 beta. And also here we will write that theta equals to 2 beta. And you can see from the drawing that angle theta minus this angle, that is angle beta, it is equal to angle NPS. Again, angle theta in the red color minus angle beta equals to angle NPS, this angle. Angle theta is 2 beta, and this angle is beta. So 2 beta minus beta is equal to this angle, that is actually angle NPS. Okay, so angle NPS equals to beta. Likewise, if you focus on this angle is a right angle, it equals to 90 degrees, angle MSN equals to 90 degrees. And this angle, it is given us the question that angle PSQ equals to 45 degrees. So here 90 degrees minus this angle that is 45 degrees will be equal to angle PSM. This angle equals to 90 degrees minus 45 degrees. That is to say 90 degrees minus 45 degrees is 45 degrees. Okay? So in the next step, we will prove that triangle PNS is congruent to triangle PMS. So I will draw those two triangles together and we will prove that they congruent to each other. Okay, so we have triangle PNS. So this is triangle PNS. we prove that it's congruent to triangle PMS. So we will prove the triangle PNS, the green triangle, is congruent to the white triangle, triangle PMS. So I will write it down. The green triangle, triangle PNS, congruent to the white triangle, triangle PMS. So why they congruent to each other? First of all, we have those two angles that are equal to each other, they are both equal to beta. So angle NPS in the green triangle is equal to angle MPS on the white triangle, and both those two angles are equal to beta. Angle NPS equals to angle NPS equals to angle MPS equals to beta. PS is a common side, it belongs to both triangles, so PS equals to itself. PS equals to PS is a common side that belongs to both triangles. And those two angles, they are both equal to 45 degrees, so angle NSP in the green triangle is equal to angle MSP on the white triangle, and they are both equal to 45 degrees. Okay, angle NSP equals to angle MSP, and they are both equal to 45 degrees. So we actually proved that those two triangles congruent to each other. Triangle NPS congruent, this is the sign of congruent, to the white triangle, triangle MPS, according to angle side angle rule. I'll repeat again. We proved that the green triangle, triangle NPS congruent to the white triangle, triangle MPS according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if you prove that two angles and the side that is located between them in one triangle congruent to two angles and the side that is included in another triangle, then you prove that those two triangles congruent to each other according to angle side angle rule. And we proved actually that those two angles and the side between them, that is to say PS, congruent in the green triangle, congruent to those two angles and the side between them, that is to say PS, in the white triangle. Therefore we proved that those two triangles congruent to each other according to angle side angle rule. And we can conclude from the fact that those two triangles congruent to each other that NS equals to MS. NS equals to MS. Those two sides are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides, that is to say NS and MS, will be equal to each other. Okay, so we will join together points M and N by a straight line, and I will draw triangle MNS in a new page. Okay, so we can write here that MS equals to NS equals to MS. Here we will also join points M and N together by a straight line. And I will draw triangle M and S in a new page. So this is a right angle, it equals to 90 degrees. And we found out that NS equals to MS, NS equals to MS. And we have the rule that in front of equal sides in the triangle there are equal angles. Those two sides are equal to each other, therefore in front of them there are equal angles. That is to say, those two angles must be equal to each other. Those two angles must be equal to each other. So if we define one angle as y, then the other angle must be also equal to y, because of the fact that they are equal to each other. So the sum of the angles in any triangle is equal to 180 degrees. This angle is a right angle, that is to say it equals to 90 degrees. So the rest must be equal to 90 degrees in order to complete the sum of the angles in this triangle to 180 degrees. That is to say y plus y equals to 90 degrees. Y plus y equals to 90 degrees in order to complete the sum of the angles in triangle NMS to 180 degrees. So y plus y equals to 90 degrees. Y plus y is 2y equals to 90 degrees. We will divide this equation by 2 and we will get that angle y equals to 45 degrees. So we found out that angle y equals to 45 degrees. So we can write here that angle y, or we'll substitute y by 45 degrees. This angle equals to 45 degrees, and this angle also equals to 45 degrees. So actually angle S and M equals to 45 degrees. So here angle S and M equals to 45 degrees. And this angle also equals to 45 degrees, according to what we found that in this triangle. And in the next step, we will prove the triangle PQN is congruent to triangle NPN. So I will draw those two triangles together and we will prove that they can congruent to each other. Okay, so triangle QPN triangle QPN congruent to triangle PNM. I repeat again, the green triangle PQN congruent to the white triangle PNM. So I'll write it here. The green triangle PQN will prove that it congruent to the white triangle PNM. First of all, we've already found out that PQ equals to PM. Here, PQ equals to PM. And we also know that those two angles, they are equal to each other, they are both equal to 2 beta, so angle QPN in the green triangle is equal to angle NPM in the white triangle, and both angles are equal to 2 beta, and side PN is a common side, it belongs to both triangles, so PN equals to PN is a common side that belongs to both triangles. So actually we proved that the green triangle PQN congruent to the white triangle PNM according to side rule. I repeat again, we actually proved that the green triangle PQN congruent to the white triangle PNM according to side rule. So what is side rule? Side rule is that if you prove that two sides and the angle that is located between those two sides in one triangle congruent to two sides and the angle between them in another triangle, then you proved that those two triangles congruent to each other according to side rule. And we actually proved that those two sides, that is to say PQ and PN in the green triangle, and the angle between them, that is to say 2 beta, congruent to those two sides, that is to say PM and PN, and the angle between them, that is to say 2 beta, in the white triangle. Therefore, we prove that those two triangles congruent to each other according to side rule. From the fact that those two triangles congruent to each other, we will conclude that QN equals to MN. QN equals to MN. So we can write here that also QN equals to MN. They are equal to each other according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides, that is to say QN and NM, will be also equal to each other. We will join points Q and M together by a straight line, and I will draw triangle Q and M in a new page. Angle MQN equals to X, so we can write here that angle MQN equals to X, and I will draw triangle QMN in a new page. angle MQN equals to X. You can see it from the drawing. And we found out that QN equals to MN. QN equals to MN. In triangle QMN, we have two sides that are equal to each other. QN equals to MN. And according to the rule that in front of equal sides there are equal angles, we will get that those two angles that are located in front, the equal sides QN and MN, will be equal to each other. So those two angles must be equal to each other. Okay? But this angle equals to X, so this angle must be also equal to X because of the fact that those two angles are equal to each other. Okay? And this point is point S. So in triangle QMN, we have three interior angles. Those two angles are interior angles, and this angle is also interior angle. And angle MNS, this angle is defined as the exterior angle of triangle QMN because it is located outside triangle QMN. Okay? And according to rule number 4, the value of the exterior angle MNS is equal to the sum of the two angles that are not adjacent to it. And the only two angles that are not adjacent to it are those two angles. And the sum of those two angles is x plus x. X plus x is 2x. So we found out that according to rule number 4, angle MNS, this angle is equal to 2x. According to rule number 4, angle MNS is equal to 2x because it equals to the sum of the two angles that are not adjacent to it, that is to say it equals to x plus x. From one side, but from the other side, the value of angle MNS, we have already found out that the value of angle MNS is equal to 45 degrees. The value of angle MNS is equal to 45 degrees. So actually here, from this equation, we will derive that 45 degrees equals to 2x. 45 degrees equals to 2x. Here we will divide this equation by 2, and we will get that x equals to 45 degrees over 2. 45 degrees over 2 is 22.5 degrees. So we found out that the value of angle x is 22.5 degrees. Okay, so now I will summarize the lecture. Actually, we found the value of angle x in two different methods. In the first method, we have here triangle PQR. We know that angle PSR equals to 45 degrees. Angle PQS is 3x and angle PRS is x. And we want to find out the value of angle x. We defined angle QPS as alpha and angle SPR as beta. And then I presented to you actually here we found this angle according to the rule that the sum of the angles on one side of a straight line must be equal to 180 degrees. So QR is a straight line if we focus on the upper side of the straight line QR at point S, the sum of the angles must be equal to 180 degrees. So if we define angle PSR as y, then we will get that 45 degrees plus y must be equal to 180 degrees according to the rule that I mentioned. So here 45 degrees plus angle y must be equal to 180 degrees. We subtracted 45 degrees from this equation and we got that angle y equals to 145 degrees. So we found out that angle y equals to 135 degrees. Then I presented to you a new rule. This is actually the law of sines. The law of sines is true in any triangle. So in any triangle, if we have this triangle that could be any triangle, and we know that the length of this side is A units, the length of this side is B units, and the length of this side of the triangle is C units, and we also know that this is angle alpha, this is angle A, this is angle B, and this is angle C. Then according to the law of sines, A over sine A equals to B over sine B equals to C over sine C. So from this formula we will derive that A over sine A equals to B over sine B. We will divide this equation by B and we will multiply it by sine A, and we will get that A over B equals to sine A over sine B. And what is the meaning of this equation? The meaning of this equation is that the ratio between the side lengths of any triangle is equal to the ratio between the opposite angles. Okay? Then in our drawing we can create the equation that states that PS over QS equals to PS over SR. Okay, PS over QS equals to PS over SR, and it is true because of the fact that QS equals to SR according to what is given us in the question. But according to the equation that A over B equals to sine A over sine B, we will get that PS over QS, if we focus on triangle PQS, must be equal to sine 3x over sine alpha. PS over QS equals to sine 3x over sine alpha. And if we focus on triangle PSR, then PS over SR must be equal to sine x over sine beta. PS over SR equals to sine x over sine beta according to equation that A over B equals to sine A over sine B. Okay? Then we know that the sum of the angles in any triangle is equal to 180 degrees. So if we focus on triangle PQS, the sum of its angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees must be equal to 180 degrees. We subtracted 3x and also 45 degrees from this equation number 2, and we got that angle alpha equals to 180 degrees minus 3x plus 45 degrees. Then we focus on triangle PSR, and on triangle PSR the sum of the angles must be equal to 180 degrees. That is to say, beta plus 125 degrees plus x must be equal to 180 degrees. And here we subtracted 125 degrees from this equation number 3, and we also subtracted x from this equation number 3, and we got that angle beta equals to 45 degrees minus x. So after we found out the value of alpha and beta in terms of x, we can substitute alpha and beta in this equation number 1, by the values that we found in equation number 2 and equation number 3 for alpha and beta. So we did it here, and we got that sine 3x over sine alpha, and we found out that the value of alpha according to equation number 2 is 180 degrees minus 3x plus 45 degrees, and it equals to sine x over sine beta. And we found out that beta equals to 45 degrees minus x according to equation number 3. And we have the trigonometric identity that sine 180 degrees minus theta equals to sine theta. So we can substitute this expression by sine 3x plus, so according to this trigonometric identity, sine 180 degrees minus 3x plus 45 degrees will be equal to sine 3x plus 45 degrees. So we can substitute this expression in equation number 1 by sine 3x plus 45 degrees. So we did it, and we got equation number 1 states that sine 3x over sine 3x plus 45 degrees equals to sine x over sine 45 degrees minus x. Here we cross multiply the equation number 1. We got this expression. Then we multiply this equation number 1 by 2. We got this expression. And we actually simplified the two sides of equation number 1 by using the trigonometric identity that 2 sine A sine B equals to cosine A minus B minus cosine A plus B. And in our specific expression, A equals to 3x and B equals to 45 degrees minus x. And cosine A minus B will be equal to cosine A is 3x and B is 45 degrees minus x, so it is 3x minus x. 3x minus x is 3x plus x, that is to say it equals to 4x, and 0 minus 45 degrees is minus 45 degrees. So here we got cosine 4x minus 45 degrees, and we also have to subtract cosine A plus B. Here cosine A plus B, A is 3x and B is 45 degrees minus x. So A plus B is 3x plus minus x. 3x plus minus x is 3x minus x. 3x minus x is 2x. And 0 plus 45 degrees is 45 degrees. So in conclusion we got here that it is cosinus 2x plus 45 degrees. Okay, so we finished with this side of equation number 1. Then we treated the other side of equation number 1. Here A equals to x and B equals to 3x minus 45 degrees. And cosine A minus B is actually A is x and B is 3x plus 45 degrees. So A minus B is x minus 3x. X minus 3x is minus 2x. And 0 minus 45 degrees is minus 45 degrees. So in conclusion we got here cosine minus 2x plus 45 degrees. But because of the fact that cosine minus x equals to cosine x, we can substitute the negative sign to a positive sign. We did it, and we got here cosine 2x plus 45 degrees. And here we also must subtract also cosine A plus B. Here A plus B is x plus 3x, that is to say it is 4x, and also it is 0 plus 45 degrees, it equals to 45 degrees. So we got here minus cosine 4x plus 45 degrees. So what we have here in equation number 1, we have cosine 4x minus 45 degrees. So I copied this expression here. And we have here minus cosine 4x plus 45 degrees. So we added to equation number 1 cosine 4x plus 45 degrees. And we have here minus cosine 2x plus 45 degrees. So we added to this equation cosine 2x plus 45 degrees and cosine 2x plus 45 degrees plus cosine 2x plus 45 degrees equals to 2 cosine 2x plus 45 degrees. Then the expression cosine 4x minus 45 degrees plus cosine 4x plus 45 degrees is very similar to the trigonometric identity that cosine c plus cosine d equals to 2 cosine c plus d over 2 times cosine c minus d over 2. And also the expression 2 cosine 2x plus 45 degrees is very similar to the trigonometric identity that cosine a plus b equals to cosine a cosine b minus sine a times sine b. So we treated this expression according to this trigonometric identity. Here C equals to 4x minus 45 degrees and D equals to 4x plus 45 degrees. And according to this trigonometric identity, cosine C plus cosine D equals to 2 cosine C plus D over 2. C plus D is actually 4x plus 4x, and C plus D over 2 is 4x plus 4x over 2. 4x plus 4x over 2 is 8x over 2, that is to say it equals to 4x. And minus 45 degrees plus 45 degrees is 0. So in conclusion, we got here that 2 cosine C plus D over 2, it is actually 2 cosine 4x. And we also must to multiply it by cosine C minus D over 2. Here C minus D is 4x minus 4x is 0. And we also have minus 45 degrees. Minus 45 degrees is minus 90 degrees, and minus 90 degrees over 2 is minus 45 degrees. So we got cosine minus 45 degrees, but because of the fact that cosine minus x equals to cosine x, we can change the sign of minus 45 degrees to plus 45 degrees. So in conclusion, we got here cosine 45 degrees. So we finished with this side of equation number 1. Then we treated this side, 2 cosine 2x plus 45 degrees, according to the trigonometric identity that cosine A plus B equals to cosine A cosine B minus sine A sine B. Here A equals to 2x and B equals to 45 degrees. And according to this trigonometric identity, cosine A plus B equals to cosine A cosine B. So it is actually cosine 2x cosine 45 degrees minus sine A times sine B. That is to say, it equals to minus sine 2x sine 45 degrees. And you also must to multiply it by 2 because we have here 2 cosine 2x plus 45 degrees. So we must multiply both sides by 2. Okay? Then we divided this equation by 2 cosine 45 degrees. So 2 cosine 45 degrees get cancelled. Here also 2 cosine 45 degrees get cancelled. And here 2 sine 45 degrees get cancelled because of the fact that sine 45 degrees equals to cosine 45 degrees. So what is left from equation number 1 after we cancel 2 cosine 45 degrees? What is left? It is actually cosine 4x equals to cosine 2x minus sine 2x. Here we added to this equation number 1 sine 2x, and we subtracted cosine 4x, and we got that sine 2x equals to cosine 2x minus cosine 4x. Okay, and we know that sine 2x equals to 2 sine x cosine x, and cosine 2x minus cosine 4x is very similar to the trigonometric identity that cosine C minus cosine D equals to 2 sine D plus C over 2 times sine D minus C over 2. And here, C in our specific expression, C equals to 2x and D equals to 4x. So 2 sine D plus C over 2, it is actually 2 sine 2x plus 4x over 2. 2x plus 4x is 6x, and 6x over 2 is 3. So we got 2 sine 3x, and we also must to multiply it by sine D minus C over 2. Sine D minus C over 2, D is 4x, C is 2x, so D minus C is 4x minus 2x. 4x minus 2x is 2x, and 2x over 2 is x. So in conclusion, we got here sine x, so this expression equals to 2 sine 3x sine x. According to this trigonometric identity of cosinus 3 plus cosinus D equals to 2 sine D plus C over 2 times sine D minus C over 2. Okay? Then we divided this equation number 1 by 2 sine x, and we got that cosine x equals to sine 3x, and according to the trigonometric identity that cosine alpha equals to sine 90 degrees minus alpha, we will get that cosine x equals to sine 90 degrees minus x, and it equals to 3x. Sine 90 degrees minus x equals to sine 3x means that 90 degrees minus x equals to 3x. We added to this equation number 1 x, and we got that 90 degrees equals to 4x. Then we divided this equation number 1 by 4, and we got that x equals to 90 degrees over 4. That is to say 90 degrees over 4 is 22.5 degrees. So we found out that the value of angle x according to the first method is equal to 22.5 degrees. So we finished with the first method. Then I presented to you how to find out the value of angle x according to the second method. In the second method, we define this angle as alpha, this angle as beta, and we already found out that this angle equals to 135 degrees according to the first method. And we also know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, in triangle QPS, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 3x plus 45 degrees equals to 180 degrees. We subtracted 45 degrees from this equation number 1, and we got that alpha plus 3x equals to 135 degrees. Likewise, in triangle PSR, the sum of the angles must be equal to 180 degrees. That is to say, beta plus 135 degrees plus x equals to 180 degrees. Here, we subtracted 135 degrees from this equation number 2, and we got that beta plus x equals to 45 degrees. Then we multiplied the equation number 2 by 3, and we got that 3 beta plus 3x equals to 135 degrees. So we have 135 degrees in both equations, equation number 1 and equation number 2. So we can write down that equation number 1 is equal to equation number 2, that is to say alpha plus 3x equals to 3 beta plus 3x. We subtracted 3x from this equation number 3, and we got that alpha equals to 3 beta according to equation number 3. Then we made the construction. Here from point Q, we draw a straight line to PR in such a way that angle MQR will be equal to x. Okay, so angle MQR equals to x. So if angle MQR equals to x, the whole angle of QPR equals to 3x, and this angle equals to x. So the rest must be equal to 3x minus x. That is to say, angle PQM must be equal to 3x minus x, and 3x minus x is 2x. Okay? And then I actually presented to you rule number 4. According to rule number 4, the exterior, but before that, actually we joined, so we know that triangle QMR is an isosceles triangle because it has two angles that are equal to each other, they're both equal to x, and the base of the isosceles triangle QMR is QR. We join points M and S together by a straight line. We know that the median to the base is perpendicular to the base, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay, then I presented to you rule number 4. According to rule number 4, the exterior angle of a triangle is equal to the sum of the two angles that are not adjacent to it. So what is the meaning of rule number 4? The meaning of rule number 4 is that if we have this triangle and alpha, beta and gamma are the interior angles of triangle ABC, and angle AB is the exterior angle. According to rule number 4, the value of the exterior angle SAB is equal to the sum of the angles that are not adjacent to it. Those two angles are not adjacent to SAB, therefore it equals to alpha plus beta. The value of the exterior angle SAB is equal to alpha plus beta. We can implement rule number 4 in our drawing. In our drawing we have the isosceles triangle, triangle QMR, and angle PMQ is an exterior angle of triangle QMR, and it equals to the sum of the angles that are not adjacent to it. That is to say, it equals to x plus x. So angle PMQ equals to 2x, but angle PQM also equals to 2x. So triangle PQM is an isosceles triangle, and we know that in front of equal angles in the triangle there are equal sides. That is to say, PQ must be equal to PM, because those two sides are located in front of the equal angles. So PQ equals to PM. Then we draw perpendicular from point P to QM. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. We extended the perpendicular until it touches QS at point N. And then we actually proved that those two triangles actually are similar to each other. Actually, we have those two angles, they are equal to each other, they are both equal to 90 degrees. Those two angles are also equal to each other, they are equal to 90 degrees, and those two angles must be equal to each other according to third angle theorem. Angle QPL equals to angle LPM according to third angle theorem. That is to say, those two angles are equal to each other. So if this angle is theta, then this angle must be also equal to theta. From the drawing you can see that theta plus theta equals to alpha plus beta. Theta plus theta equals to alpha plus beta. Theta plus theta is 2 theta, it equals to alpha plus beta. But we have already found out that alpha equals to 3 beta, so we can substitute alpha by 3 beta in this equation. So we got that 2 theta equals to 3 beta plus beta. 2 theta, 3 beta plus beta is 4 beta, so we got that 2 theta equals to 4 beta. We divided this equation by 2 and we got that theta equals to 2 beta. Here we can write down that theta equals to 2 beta, and here also theta equals to 2 beta. You can see from the drawing that theta minus beta equals to angle NPS. So theta is 2 beta, 2 beta minus beta is beta, so angle NPS equals to beta. Here this angle is 90 degrees, minus this angle, that is 45 degrees, must be equal to angle MSP. That is to say, angle MSP equals to 90 degrees minus 45 degrees is 90 degrees. Then we proved the triangle PNS is congruent to triangle PMS. I drew two triangles together, and we proved that the green triangle can go into the white triangle. Why they can go into each other? First of all, those two angles are equal to each other, they are both equal to beta. We have a common side PS, and those two angles they are also equal to each other, they are equal to 45 degrees, therefore they are equal to each other. So triangle, the green triangle can go into the white triangle, therefore NS equals to SM. Okay, and S equals to SM, so I drew triangle, so we join points M and N together by a straight line, and I drew triangle M and S in a new page. So here we have, this angle is a right angle, and those two sides are equal to each other. Therefore, those two sides must be also equal to each other. So they are equal to each other, and we know that the sum of them is 90 degrees. So if each angle must be equal to 45 degrees, so those two angles are equal to 45 degrees. That is to say, this angle M and S is 45 degrees, exactly as this angle M and S that equals to 45 degrees, and this angle also equals to 45 degrees. Then we prove the triangle PQN is congruent to triangle PNM. I drew put two triangles together and we prove that they can go into each other. Why they can go into each other? First of all, we know that PQ equals to PM. We have already proved it. Those two angles are equal to each other, and we have also a common side. So PM equals to PN. We have proved that those two triangles can go into each other according to side angle side rule. Therefore, MN equals to QN. So I draw triangle MNQ again, and we got here triangle MNQ. We know that MN equals to QN, but we know that this angle equals to X. So this angle must be also equal to X, because in front of equal sides in the triangle there are equal angles. So if this angle is equal to X, this angle must be also equal to X. And the exterior angle of triangle MNQ will be equal, according to rule number 4, to the sum of the angles that are not adjacent to it. That is to say, it equals to X plus X, that is 2X. So we found out that according to rule number 4, the value of angle MNS is equal to 2X. But we have already found out that angle MNS equals to 45 degrees. This angle equals to 45 degrees. So we have the equation. This equation we can derive from this equation that 45 degrees equals to 2x. We divided this equation by 2 and we got that angle x equals to 22.5 degrees. So in both methods we found out that the value of angle x is 22.5 degrees. Okay, thank you very much.